Okay, there you go.
All right, great. Thank you, Peter. Wanted to say thank you to Peter and to Rick and everybody else who put this together. It's been a great program so far. As mentioned, I'm David Workman. I'm with Vizrt, the VP of the News Automation Systems. And you know, it sounds kind of like a bit of a dry topic, achieving redundancy in automated news production systems. But as I talked to Peter about this, and you know, it's one of these topics where it kind of gets down to the core of a lot of things in the news production environment. So in general, broadcast engineers tend to be a risk-averse bunch, and I would go to say that they tend to be a little bit on the paranoid side at times, actually, because you don't want to be the one that has to get up in front of the CEO and say why your station went off air. So when you look at any piece of equipment or anything that you put into the production workflow environment, you really have to look at the reliability and the redundancy of that component to make sure that it really will perform as you need it to. So historically, when you looked at how you did redundancy in a control room, the traditional way to do it was to have a fully redundant control room, was to have two of them. So you basically built a mirror image of the entire setup. But that's not very efficient. It really is, you know, it's double the cost of all the equipment. You have the space itself, which, you know, has been getting more and more expensive as time goes on. And then just from an engineering standpoint, keeping all of the hardware and software revisions synchronized, you know, keeping all the updates and patches applied, making sure that, you know, everything is operating exactly the same level is a pain. And if you really want it to be a true hot standby, meaning that, you know, if your main control room goes down and you got to run over to the backup control room, it's got to be powered on and running all the time. So you have your extra power and AC costs and everything else on top of that. And then when you do need to use it, you know, it's like, you know, there's a problem, something goes down, you lose your connection to your newsroom computer system, whatever it is. It's a bit of a fire drill. Everybody's got to get up out of their seats. You go to a commercial break. The intention is that you get over to the other room, everybody gets sat down before the commercial break is over. You sit down in all your positions, and somebody says, oh, I just need to reboot this one thing. It's actually okay, you know, everybody can go back again. So, it really isn't the best way to have a redundant news control room. I mean, you know, it does work, but it's not very efficient. So as time has gone on, I think that model has pretty much gone away for the most part. In general, the broadcast equipment is much more reliable than it has been in years past. And over the last 10 years, there's been this move to automated control rooms. This is primarily done to reduce on-air errors and to make a better quality program, but there's also efficiencies in reducing costs and other advantages that you get with it. But there's always been a fear that when you add an automation news production system, you have one central system that controls everything in the news production environment, and that one system is a potential cause of failure. And, you know, so how do you have a backup to that automation system? And if it's not done right, it still, you know, has a bit of a risk there, in that, you know, it really is the central core part of your production environment. So if the system is architected properly, you really can provide a higher reliability than a non-automated control room. And we're going to kind of go through how we've approached that with the Vizrt system. First off, just stepping back a little bit, power. Everybody talks about, you know, having dual power supplies in all their equipment, and traditionally that has been to protect against a power supply failure. Because I still talk to, you know, some of my friends that work in hardware manufacturers. I've asked them, you know, what's the one component that goes down most often, and they pretty much always say the power supply. You know, so if you have two power supplies, you have them both plugged in, one of them goes down, you know, the thing will still work. But really, you really should have that second power supply on a separate breaker, you know, and to protect for a breaker that goes down. If you really want to get paranoid about it, you know, have a separate feed from the power company, or even a separate feed coming in at different sides of the building. If you can afford it and have the luxury, a battery backup / generator system is really the ideal way to go. You really want to have that secondary circuit on a battery backup. The battery backup should have enough capacity to last at least till you get the generator up online, and that's kind of the ideal system. But getting back into the control room itself, when you're looking at an automation system, the system itself needs to be designed from the ground up with a reliability architecture in mind. And here's an example of how to do it. I'm not going to say this is the only way to do it, but this is how we've done it with the Vizrt automation system, which has frankly served us very well. When you have your automation server, you have a main and a backup server. In between those two servers, we've implemented a heartbeat so that both of the automation servers run in parallel. And then both of those are also connected to your main and backup newsroom computer system. So whether that's iNews or ENPS or Delete or Octopus or whatever newsroom system you're using. And then controlling all of the equipment, the devices that are under the automation control, such as your playback server, your video switcher, your audio mixer. These are just examples. You also have your graphics systems. If you're connected to a Viz1 MAM system, you can talk to John Dannenbaum over there about that maybe later on. So you have all of your systems that are connected to the automation, and then you have the clients that are running the automation system from the client side. These are the user interfaces that you have for running the system. And then for every single one of those pieces, you have a completely separate connection to the backup. And this provides an architecture where pretty much it's a 0 point of failure system where any one of those devices, any one of those cables, any one of the NIC interfaces can go down, and the system can still operate, pretty much in a flawless manner. So let's look at each one of those kind of one by one. And so anything that's connected by IP, so your graphics systems, your video playback servers, you really want to have separate network switches. If you only have one, that's probably fine. Actually, most places do operate with one, but if you really want to have a true, fully redundant system, you'll have separate switches, completely separate networks. Each of your automation servers, main and backup, have separate connections to those. Each of those have dual power supplies, blah, 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 down the line. So that really gives you the ideal redundancy. It just happens that in the broadcast industry, we still have a lot of things that use RS-232 and RS-422. It's an old standard, but it's served us well. And when you have serial connections to all of your equipment, the easiest way to do it is to have a PCI card in each server. You have your main server going to one port on in this case, the switcher, and each port is connected to the main and the backup automation server. If your equipment is very close to the automation servers, it's in the same rack, that's a fine solution. But a lot of times things are separated. And so in that case, what we would do is go through a RS-232 or 422 to IP terminal server. So in this case, I've used the Moxa 2650. This is actually a really slick device because the Moxa 2650 itself has dual power supply. It supports dual networks. So you can have on the same switches that you have control over all of your other IP-based devices going to that converter. That gives an RS-422 control to the device. So if you have to go a long distance, if you have a device that only has one RS-422 port on it, or if you are running virtualized servers, then this is a great solution. And just a quick note on virtualized servers. There's a lot of broadcasters that I've found that love the idea of having virtual servers. In itself, it's kind of the ideal of true redundancy on the server side, and there's other broadcasters that say, no way, there's absolutely no way we'd even consider that. So I hear both extremes. I'd be curious to see what everybody's opinion is about that. But in this environment, we can run either way. We can run the Vizrt automation servers either on physical PCs or on a virtualized network. And again, if your switcher or whatever it is that you're connecting to only has one port, that's really the best way to have that connection done. Now, so we have IP-based connections. We have RS-232 and 422. We also have some devices that are connected through MIDI, specifically lighting desks. There's a lot of lighting desks out there that have MIDI control, and Yamaha audio mixers. So again, the traditional way to connect those up would be to have either a MIDI PCI card in the server itself, and then you just use a MIDI merge, a passive MIDI merger for the redundancy to get both the main and the backup connected. Again, that's great for short distances, but doesn't do very well for really long distances. So very similar to what we've done with the RS-422 control, if you have a terminal server, a MIDI terminal server like the KISS box, is a great choice. Basically, it's the same equivalent functionality for MIDI as the other one is for the RS-422. It gives you a long-distance solution. It works great with virtual servers and gives you the full redundancy. So if the system is properly implemented, you should be able to hot switch back and forth between the main and the backup automation server pretty much instantly. With the Vizrt system, that's usually less than 1 second, and the backup server can take control over all the equipment in the gallery, usually in less than 3 seconds. So if you have something that you see is acting kind of funny, you can play a 3-second video clip, say switch to backup. By the time that 3-second video clip is finished playing, the backup server will grab control over all the equipment in the gallery, in the control room, and you'll be under backup control. But you're still at risk from failure within each device. So you have, you need to look at how you protect against a backup in an individual piece of equipment. So here's some examples for that. So on the video servers, I put this one first because of all the devices in the control room, the video servers are probably what's most failure prone. You queue up a server and it just doesn't queue up. So having an automation system that can play mirrored servers is pretty critical. So not just AB roll or ABCD roll, but mirroring an A2, B2, C2, D2 roll as well. So whenever you roll any channel, you have a backup mirror roll of that same channel. Preferably on a different chassis, again, if you want really a full redundancy, but it doesn't have to be. And it's nice if, with something like the Vizrt automation system, where you can mix and match servers from different manufacturers. So this is especially good if you want to upgrade some older servers to a newer one. You want to use the older ones still in your pool as a backup, so you can have them still there in the pool, have them as the mirrored channels, and they don't have to be of the same manufacturer, so you can mix and match there. So another thing that's really good to be able to do is to be able to scrub through your clip in preview. So, again, you're about to go on air, you call up a clip, it goes to the preview monitor, and if you see the first frame in preview, it's probably a good chance that your server is acting fine and you actually have your clip there. But if the first frame of your clip is black, you're going to have a black frame there, and you might not know whether that's queued up properly or not. So it's nice to be able to scrub through from the automation system your clip, just to give a quick scrub and make sure that your server is working fine and you got the right clip there. You can swing it back to the beginning, hit play, and you know that clip is going to play. And the operator should be able to, if there is a problem, switch to the backup playback servers before it actually goes on air. That's kind of the ideal goal. And also, the automation system should be able to completely remap all of the audio faders and video cross points on the fly. The operator that's running the system shouldn't need to worry about, I'm on cross point 37 versus 36 because I'm on the backup server, and the faders have all changed. Everything should be able to be completely remapped in the automation system, so that the operator just keeps running the show. It should be absolutely no difference in running the program. So on the switcher side, switchers again are quite reliable. It's pretty rare to have a video switcher go down, but stuff happens, and there are times where you'll have either a mix effect board go down or a power failure or something. Having the ability to control a router as a shadow switch for the switchers is actually a pretty good idea. And this is something that if it's set up and your templates are set up properly, every time you take a cross point on the switcher, you'll shadow that same cross point on the router as a backup output. So again, you have your main and backup automation servers controlling the video switcher and then the plant router in parallel, both of them with parallel connections, giving you the primary program output out of the video switcher and then your backup program output out of the router. So that's, again, how we've approached that problem. You're not going to get your Weatherman's chroma keys, you're not going to get your fancy transitions or your DVE2 boxes, but you're going to still continue to cut cross points and stay on air and be able to, get through your show. And this is actually a pretty powerful configuration. So then the last piece of the puzzle is the automation client UI, because having a client-server UI model where you're running the automation clients on a separate PC from the server PC means that you can have multiple copies of that client UI running, in different locations. So typically, our standard typical configuration is that in the control room, you're going to have a main and a backup client program running. Again, both of those, connected to the servers through that redundant connection. But you can also have other client PCs elsewhere in the facility, typically in browse mode. In the Vizrt operation, you can put a client into browse mode so it can look at the rundown as it's happening. You can scroll through it, but if somebody accidentally presses keys on the keyboard, it's not going to actually start switching the show. But we actually have a customer in Europe, and this isn't a small local station. It's a relatively large, influential national broadcaster that has completely done away with their control room, and they're actually running their entire news show from one client PC that's out on the journalist floor. So they have, they wanted to have the director and the producer out there with the journalist. You can actually see them through the glass behind the anchor's desk. When you look through the back of the glass and you see the news floor back there, the director and the producer are switching the show live right from, right out there in the open, and they've completely done away with their control room 100%. And they've been running like that for about 3 years now. So it's an interesting model, because when you have an installation like this, it gives you not only that true zero point of failure architecture where any single piece of equipment, any single cable, any single power supply can go down and the system is protected from that failure, but it gives you a smaller footprint than even a single control room. So instead of having a completely backup 2 control rooms, each of them fully staffed with 8 to 10 people, it gives you, a smaller footprint than the single control room. And you can really operate any size show. Large national broadcast, 24-hour-a-day news shows, sports shows, talk shows, elections, anything like that, with 1 to 2 people rather than 5 to 10 in your typical control room. So you get a higher quality show, more consistent newscast with less errors, and at the end of the day, it translates to lower operational costs. And I think that's kind of the key that we're all looking for. So I know I've kind of whizzed through that in record time. Anybody have any questions?
Robotic cameras?
Yep, robotic cameras. Doing the redundancy on the robotic cameras is a little bit problematic, because usually you have one controller that's controlling all of the cameras, so you can have a dual connection to that controller, but it's hard to have a backup for the controller itself. And there are ways to do it, but that's a little bit more tricky configuration.
How about the audio? You mentioned the European client.
Mm-hmm. Yeah, well, with the Vizrt automation system, you can run the full audio right there from the single operator, and that's the way most of our customers are running it. I mean, if you want to have a full backup mixer, usually they'll have a smaller mixer, you know, again, a small Yamaha or something like that, rather than the full Cowrec or SSL, you know, that's running the main audio. So you'll have a backup of a, you know, something that just has your primary channels. But as far as operationally, yeah, there's no reason why you can't operate it from that single operator station. Any other questions? All right. Whoop. Great. Thank you.